Okay, so this video is going to show us what we do with our data and how we go ahead and calculate the concentration of an unknown solution using the Beer's law equation. So we're using Beer's law. This is not beer as in like the drink beer, but the name of a scientist. I can't remember his first name, Beer's law. But Beer's law relates um, the absorbance using a spectrophotometer to the concentration. And the equation is pretty easy. It's A, absorbance in a spectrophotometer is going to be equal to some constant we'll call K times the concentration C. Okay, and so if we want to figure out what the concentration of a solution is, you go ahead and take its absorbance, divide by K, and that'll give you the concentration. We can divide both sides by K, and we can solve this equation for C. C is equal to A divided by K, whatever that K is. All right, so this is the absorbance from the spectrophotometer. Absorbance from the spectrophotometer. Spectrophotometer. Run out of space. And K here is a constant that we're going to get from graphing. Okay. So it's basically the slope from a graph of its absorbance versus concentration of known solutions of known concentration. Okay. So that's what we're going to do with your data. When you did this lab, you did absorbances of 5 solutions with known concentration. Known concentration. And you're going to use those to make the graph. You use these to make the graph so you can come up with the slope. Then you have absorbances of 2 solutions of unknown concentration. Unknown concentration. Not easy writing on this thing. And you're going to go ahead and find these unknown concentrations here by using that K. Once you find what that K is, then you can just go ahead and take the absorbance for each one of these, plug it here, divide by K, and that's going to give you the concentration for these two. So you should have 7 absorbances, 5 that you did with concentrations of solutions of known concentration, which you created by diluting a solution, and then 2 of them that you were just given to you, and you just took the absorbances. Right? We're trying to figure out what the concentration is here. So that's what this video is going to be about. If we're going to put it in parts, the first part is to try to figure out how to turn the percent T, percent transmittance, which is what you took from the Beer's law, from the spectrophotometer. I'm going to turn it into absorbance. Why do we go ahead and read percent transmittance versus absorbance, since you can actually read absorbance on the spectrophotometer? These two relationships are not linear, they're logarithmic, which means that they don't translate directly. And what you've got to do is you got to use an equation to get one from the other. It's much easier to read the percent transmittance on the spectrophotometer than it is to read the absorbance. So we're going to read that, and then we're going to go ahead and turn it into absorbance. Um, it's harder to read the absorbance because, once again, it is we call logarithmic, which means that the scale changes as you move up the machine, and it makes it a little bit harder to read as you go up the machine. So You'll probably get better data by taking the percent transmittance and then turning it into absorbance. Okay, so we're going to use a Google Sheet in order to do this. Now you can do this first part by hand. Now, if you're not interested in doing this, if you know how to do this already, you can skip to the next part. I'll chapter this uh, this video so that you can see when we're starting to make the graph. Okay, and you can just plug in all your data. Okay, but you're going to need a graph so that you can come up with this the slope of that graph, and then that's going to be our k that we're going to use. So let's say that we had the following data from our diluted known concentration solutions. We had, let's see, I, I'm going to go ahead and use this data from an old lab. Yours might be different, but there's going to be different concentrations and percent transmittance or percent T. And you just go ahead and put down your concentration should have been, you should have 5 different concentrations. I think in the past here, I used a stock solution that was 0.2, that was 1.0 molar, and then I diluted it to 0.2, 0.4, 0.6, 0.8, and 1.0. And we got the following transmittance of 88 for the first one, 77 the second one, 70 for the third one, 60 for the fourth one, and 52 for the last one. Okay, so this is the data you should have. This is for the 5 diluted solutions that you should have. You should also add a 6 point. The concentration is 0. The percent transmittance should also be, well, actually, no. The absorbance will be 0. That'll be in another one. Okay. Now, in order to turn percent transmittance into absorbance, we need to use the following equation. Let me see if I can move this thing here. All right, so there's the following equation relates percent transmittance to absorbance. The absorbance is equal to 2 minus the logarithm of the percent transmittance. Percent transmittance. Let me go ahead and get rid of that. A little bit better. Percent transmittance. So whatever your percent transmittance is on a calculator, plug it in, hit the log button, and then take 2 minus that, and that'll give you your absorbance. Okay. Now, if you can do that by hand, and if you want to do it by hand, it's actually not that hard to do it by hand and plug the numbers in. I'm going to show people in this part of the video how they can do it using the formula, using a spreadsheet, because you can have the spreadsheet do it. Like, for example, right here, what we want to do is we want to turn the transmittance into absorbance. And we're going to use that formula. Um, so this next one should be absorbance. I'll put ABS for absorbance. And the other one's percent transmittance. Now remember, the formula is 2 minus the logarithm of percent T. Okay. If you don't know what a logarithm is, it's basically just kind of an exponent 10 to whatever that logarithm is. That's that 10 to the x is equal to a certain number, right? So 10 to the 10 to what number? 10 to what x equals 88, basically, and you're solving for x. Your calculator will do it for you. You don't have to do it by hand. Here's the deal: since the absorbance formula is 2 minus the, I'll write it up here, minus the log of the percent transmittance. We're gonna have to do something here so we can get the absorbance here. Um, you can go ahead and get a logarithmic function in the spreadsheet here in Google Sheets, but I haven't found a way where I can just go ahead and write out the equation and then put the function in the middle. So what I'm going to do is I'm going to go ahead and make a column that is a logarithm of percent t, because I know how to do that. Okay, and then I'll just make this one 2 minus whatever that is here. Okay, so we want the logarithm of percent t right here, the logarithm of this number. In order to get that, you can go and insert a function. Here, right, so go to the insert menu, then down insert a function, and then you can go down to math functions and look for log, and you're going to look for log 10. Log 10, not I am log 10, that's a different thing. Log 10 right here, the logarithm of a number of base 10. Okay, because 10 will be the base number, and then you're looking for the exponent to make that number. You click on that and see it's looking for the log of that. And then it's asking you log of what. So you can go ahead and highlight this cell, or you can type in C4, and it tells you what the answer would be right there. Okay. And if you hit enter, that's your logarithm of 88, 1.94. In other words, 10 to the 1.944, whatever that number is equal to 88. Okay. And so you can go ahead and do that. And then in order to get the logarithms of everything else here, you can just go ahead and copy and paste all the way down, and it'll give you the logarithms of these numbers here. Now that's not your absorbance. Your absorbance is 2 minus that, minus this number. So here in the absorbance column here, now I can just go ahead and write a formula. Equals 2 minus, and then I'm going to go ahead and have it subtract this cell, which is E4. So 2 minus E4, and that's going to, and hit enter. That's going to give me this answer. And then I'm going to go ahead and, it'll ask you if you want to autofill. You could do that. In case it doesn't, I'm showing you how you can go ahead and do that. So now that I have that, and here's my formula, 2 minus whatever E4 is. Remember that E4, this cell right here, is the logarithm of C4, right over here. Then I can go ahead and just copy and paste down, and it gives me all my answers. So this is my absorbance. This is my concentration. These are the columns that we're going to make a graph with. I am going to go ahead and for concentration of 0, I'm going to put the absorbance as 0 artificially there, because we didn't take it, but you kind of did, because you zeroed, excuse me, you zeroed a blank, right? You zeroed every time you took a reading, you zeroed the spectrophotometer with a blank, with just water. So when there is no concentration, there is no absorbance, right? That's where you set the absorption there at 0, or percent transmittance at 100, basically. Okay, actually, I think it was, yeah. All right, so now we can go ahead and graph these. Once again, you don't have to do it on the spreadsheet. You could have just done this in your calculator. Take number 88, plug it in, and then hit the log button. Or some of you guys might need to hit the log button first, and then take 88. And then take that, whatever that answer is, and subtract 2 from it. By the way, this looks a little sloppy. Let's go ahead and see if we can go ahead and set a certain number of decimal places. I'm going to go ahead and put like, what, 3 decimal places? That'll work. Okay, now that we have our data, we have concentrations, this is going to be on the x-axis, and this is going to be on the y-axis. Okay, so let's go ahead and insert a chart. So you can go here, or you can go here to insert and find where it says chart. Insert chart, and once again, like last time, we're going to be we're going to be working with a scatter plot, because once again, scatter plots are the ones that put the XY values in the correct place. I'm just going to move this out of the way so I can see what I want to graph. I'm going to go to chart type and set it to scatter. Okay. And then my x-axis data range, what I'm going to do is I'm going to go ahead and get all the concentrations here on my x-axis. And then on, let's see, I don't want that F11 in there. I don't know why that's in there. And then on the y-axis, we go to add series, and you're going to put the absorbances, right? So the absorbances are right here. Click OK on that one. Right. Luckily, we've already done a graph, so hopefully this is just review for you guys. And there is my graph. You'll notice it's a nice linear graph. It should be. It should go through the origin. Okay. This one does. The line should go through the origin, but we might be off a little bit. Unfortunately, this program doesn't have the capability to set it to go through the y-intercept equals 0 through the origin. But I think if we're off just by a little bit. All right. So just like any good graph, let's go ahead and put titles on it. So that was a setup where you put the x-axis and the y-axis, or the y-axis is, they call it series in this function right here in this application. Now we go to customize to go ahead and put titles. So chart and axis titles. Let's start with the axis titles. The horizontal axis we said was concentration, and that was in moles per liter. And the vertical axis, the y-axis, is absorbance, and that has no units. Just absorbance units, whatever that is. So the title to the whole thing, the whole chart is, remember that the title is always y versus x. So what do we have on the y-axis? Absorbance. And what do we have on the x-axis? Concentration. For a solution of copper sulfate. What is copper sulfate there? I'm not going to worry about the subscript here. We got other bigger fish to fry. All right, so we've got our linear graph. We got our titles. Next thing we need to do is the slope, right? So what we're going to do is we're going to go ahead and put a trend line in there. Let me go ahead and double click on here. We're still on the customize menu, right? We open the chart editor. I should have closed it to begin with. We go down to where it says series. At the bottom of the series, the last box is trend line. You click on that, it opens up a whole bunch of stuff. And now we've got a line that best fits through our points. And what we want is we want the slope to that. So how do we figure out the slope? It's nice that we have the line, but how do we figure out the slope? And you guys saw that last time. We went ahead and put a label on it. And so you go down further down, and right here where it says label, right before it says show R squared, we can go ahead and click on the label and use equation. And it gives us the equation of the line. And basically this is the blue dot represents y. Y equals to 0.28x plus, and this is your y-intercept, negative 1.73 times 10 minus 3. It's like negative 0.00173. So it's essentially 0. Okay, so that'll work. The important thing is we want this right here, this slope, 0.28. That's going to be our k. So by looking for that, by getting that, now we know that k that we're going to be able to use. Okay, so let me get rid of this, move it over. All right, and there's a slope. See, so we're not just making this graph just to make something that looks pretty or give you something to do. What we're doing is we're making the line so that we can go ahead and figure out what the slope is for this trend right here. Some people say, why don't we just take one point and then make a line between that and the origin? But the reason why you do that is because there might be error in one. See how this one's a little bit off the line. So is this one. They're not all. Some of them are on the line. Some are just a little bit off. If you actually went from 0 through this one, the slope might be a little different. In some data, there might be some data that goes way off of the line more. So if you put all your eggs in one basket, in other words, if you just depend on just the one the 1 point, it might be off. By having 5 points, now the errors kind of offset each other, and so you get a better line through the points. Okay. All right. So now we can go back over here. Now that we know what the slope is, that's our k. So for these two solutions that you don't know the concentrations for, you just take their absorbance, divide by K, and that gets you your concentration. So now you can figure out what the concentrations are here. This is how they do all the blood tests over at the doctor's office or at the hospital. They go ahead and they make a standard curve they use every day. Then when they take your blood, they go ahead and check for things like glucose or triglycerides or cholesterol, and they get the absorbance of that substance, and then divided by the K for that they figure out for that particular substance, and it gives them the concentration. Right, so you have a cholesterol of like 200 milligrams per deciliter. Um, so we use molarity, but they can use whatever units that they need to use. Okay, and that's how you make your graph, and that's why you need to make your graph. All right, so you need to turn in the concentrations versus absorbance, and then you also need to turn in a graph, and also calculate which is basically the main thing. Calculate the concentrations of the unknown solutions. Right, the two unknown solutions that I gave you. Give me the concentrations based on this using this slope in order to help you calculate those. Okay. Hope this is helpful. If anybody's got any questions, let me know.